This is the fourth video out of 10 of the tutorials that describe setting up the simplest simulation with Lumerical software. I would like to remind you that I provide PowerPoint slides supplemental to this video tutorial. This part discusses setting up object in the simulation domain. By the end of the previous video, we have already created links between the variables and parameters of the simulation objects. We realize those links by means of short scripts. Now we start working on setting up the objects in the simulation domain. First, we go to the section Structures, the top panel, and select Sphere. The moment the object is created, its parameters are automatically populated from those we define in the script. Specifically for the sphere, we defined one geometrical parameter, which is the sphere radius, and we defined 3 coordinates for its center. To confirm that object parameters are correct and to set up other properties of the object, we access its characteristics. We right-click and we select Edit Object. For the geometrical parameters of the sphere, we see that we have its radius set up right away here. Again, it happens because we have already told the software that for the object called sphere, the radius is going to be defined by the variable SPH radius. We see that the coordinates of the center are also correct. Further, in this section Material, there is a drop-down list of possible materials one may need to use in the FDTD simulations. In our case, we are going to select silicon. Other settings in the tabs rotation and graphical rendering we keep with default parameters. We click OK. We see that the color of the sphere has changed because we changed its material and set it up to be silicon. Next, we repeat the same procedure for the second object we need to place in the domain. We go to the Structures section on the top panel again, but this time we select Rectangle. Similarly, all geometrical parameters are filled in automatically because we have already defined them using the script. We can confirm it again by clicking Edit Object. We see the dimensions are correct. For this rectangle, we need to choose the object material that corresponds to the surrounding environment. In our case, we chose the refractive index simply 1. And it corresponds to the vacuum surrounding the sphere. Similar to the sphere, we keep other parameters with the default settings. And we click OK. So we have just created 2 objects, and the geometrical parameters are defined by the variables written in the short scripts for each of these 2 objects. Now I would like to emphasize one crucial point. The order of this object in setting tree defines the material overlap in the simulations. For example, now we first put a sphere and then we put a rectangle. That means the rectangle will be inserted and override the sphere. The sphere erases in this case, and it's effectively removed from the calculation domain. Calculation would be performed as the no sphere. So the simulation would be incorrect. It is because the software assumes that there is no sphere and that the rectangle is placed on top of it. It is clearly not what we need. In fact, we actually need to do the opposite. We need to have a sphere inserted into the rectangle object. We need to revise the order of the objects. We first place our vacuum rectangle and then insert the silicon sphere. In this case, the sphere would override an overlapping part of the rectangle. For changing the object's order, we use move up and move down when we right-click on the object. We first need to put the surrounding space and then insert the sphere. There are also other ways to define material overlap. In fact, the proper way to do it is to define an index of the material. It's not a refractive index, it is computational index introduced to prioritize materials in the domain. The material with the highest priority is inserted inside the material with the lowest priority. Okay, so as always, it is essential to save the project regularly. And this completes the fourth video on the numerical simulation with the Lumerical software tool.